How's it going, stats students? This is Mr. Sheck, and this is your Stats Chapter 9 review video, meaning that this is your last review video of the class, last test of the class as well, so that's pretty awesome news. With all that being said, I have about 19 minutes until go time starts when I'm recording this during my first block prep. So that means I have to go pretty dang fast here. And I'm going to be watching the clock to make sure that I end it before the bell interrupts me. So, with that being said, I'm going to hop right into it. Use this as your answer key to check. I'm going to do brief explanations. I might not do full problems. But just know I will have an answer key for you to see in class if I don't complete a problem and you want to see the answer to it. Please just ask me in class and I can do that for you. Okay. First off, a statistical graph of two variables is called a scatter plot. Okay. Uh, pretty pretty simple there, right? The strength of the relationship between two variables is determined by the correlation coefficient known as R. Okay, that is R. The correlation coefficient, again, R, is a measure of the strength and direction of the linear relationship between two variables. Yeah, kind of goes with number two, right? R is either positive or negative, and that tells you whether it's, the direction, the positive or negative tells you the direction. The strength tells you, like if it's real close to -1, well then it's a strong negative relationship. Okay. And +1, I think you get the idea. In a simple regression analysis, if the y-intercept is negative, then there is a negative correlation between the dependent variable y and the independent variable x. That would be false. Okay, the y-intercept does not tell you the relationship. It would be the slope, which is the b, right? Not in y equals mx plus b, but in a plus bx, remember. Okay, the variable that is being predicted in regression analysis is the independent variable. Okay, that's false, right? Independent is what you're given, and then you are seeing, like, does it affect the dependent variable? Okay. Correlation coefficient of 0.95, okay, that's a pretty strong positive relationship, indicates that the strength of the relationship between the dependent and independent variable is weak. That's false, right? It would be weak if it was closer to 0, but that's really close to 1. So if it was maybe like 0.3, okay, that's pretty weak, but up at 0.95, that's pretty dang strong. Okay, moving down, what is it meant when the relationship between two variables is positive? Okay, we always start as x increases, okay, because x will always increase. If it's a positive relationship, that means y also increases. So y increases also. Okay. The regression line is also known as your line of best fit. I can't write as fast as I talk, but it's line of best fit. Okay. Sample correlation coefficient has values ranging from -1 if it's really strong, negatively correlated, and +1 if it's super strong, positively correlated. Okay. And the equation of a regression line is y hat equals a plus bx. That's the college format. Again, not mx plus b. This is where a is your y-intercept, b is your slope. Okay. Association does not imply causation. We do say that is true. Association, we cannot say implies causation because we don't know what is causing the association. Okay. The regression line always passes through the point x bar, comma y bar. That is true. Mean of your x's, comma mean of your y's will always be a point on your regression line. Okay, got about 15 minutes only, so I gotta speed up even more. The coefficient of determination, okay, that is r squared. Okay, coefficient of determination is r squared. In statistics, you will use every point in the data set to determine the equation of the regression line. Yeah, every point is taken into account, right? Like if we've had problems where it's like, okay, here's your set, but now what if we add this one point, and that does change your regression line? Every point is taken into account in a regression line. Okay. If the value of the linear correlation coefficient for the advertising expense and company sale is -0.275, find the coefficient of determination. Okay, your coefficient of determination is -0.275 squared because because it's just r squared, right? And that is 0.076, okay? Which now this is basically saying put this into a percentage, and if you would read it out, it's saying about 7.6, right? That's what this is as a percentage of the variation in the company. This is just saying what your coefficient of determination means. And that means 7.6% is explained. And if 7.6 is explained, this is asking how much is not explained, which would be 1 minus the 0.076, which is 0.924, which means 92.4%, okay, of the variation is unexplained. Okay. Again, that happens because that's not a super strong R value, right? That's not a super strong relationship, so it leads to more being unexplained than what we have as explained. Okay, so 16, use the equation of the regression line to predict the income of the car rental agency that has 200,000 automobiles divided by 10,000 for the X variable. Okay, so what we are doing here is we're going to divide this by 10,000 as they said. Okay, this is our X variable for the 200,000 automobiles, which really means we are doing 0.106. 200,000 divided by 10,000 is 20, so we're just multiplying it by 20, putting that in for X, right? And then that's plus the 0.396, okay, and that equals 2.516. Okay, which means when a rental agency has 200,000 automobiles, its revenue will be approximately 2.516 billion. Okay, that's why we found that. Okay, here we have our first first data set that we are needing to find the linear regression line. So I'm going to do this one on the calculator so that we can see how we are entering all of this stuff. Remember, hopefully, yeah, that should be good enough. You should be able to see that. I'll move my mouse. Okay, so to start entering, I don't think I'll do this for the next one. I will do it for 17 though. But for time's sake, I can probably only do it for one. So I'm going stat, edit, enter. Okay, I have to clear out whatever I currently have in here, which means I arrow up, hit clear, and then arrow down. Okay, and now I'm going to put in my X value. So I got 957, enter. 1332, enter. 1163, enter. 1865, enter. 119, enter. 273, enter. Okay, there's my X's. I arrow over to my Y's. I got 0.77, enter. 0.697, enter. Oops, I just made a mistake. So if you make a mistake, make sure you fix it. Okay, this should be 0.697. 0.697. Okay, that was I don't know. I must have just hit the 9 before I hit the 6. Now we got 0.617, enter. 0.652, enter. 1.08, enter, and 1.42, enter. Okay, make sure all of that was entered in correctly, because if you made just one mistake, of course, it will change your regression line. So I'm just checking to make sure everything looks good, that I didn't hit any wrong keys, and that every key registered. It looks good. Okay, so then I always go zoom 9 to see what we're looking like. Okay, that's your zoom stat. Okay, and then to see my regression line, I go stat calc 8. Okay, stat calc, and then down to 8 here. Okay, and here I just hit enter, 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 calculate, and it gives you your equation. It gives you your A, your B, your correlation coefficient as well, and coefficient of determination. So when we are writing our regression line, right, here's what we got. Tells me A is 1.25, tells me B is negative 3.98 e to the negative 4, so we'll talk about what that means. Okay, but it's A plus BX, so A is 1.25, I will round to, okay, plus BX, but that's really a negative B, so I'm going to go minus, and this e to the negative 4 tells me move the decimal 3 places to the left. So it's 3.98. Let's do this off to the side. Move that decimal, it's a negative 4, so move that 4 places to the left. So that's 1, 2, 3, 4, okay? Which really means, and then fill in those divots with zeros. Okay, so that's a tiny b, it's 0.00039, which I'll just round up to 0.004. Okay, and that's x. Okay, now if we were to use this for 1,600 million eggs, okay, you are putting in 1,600 in for x. Okay, putting in 1,600 in for x, and when you do that, you should get 0.61 ish. Okay, depending on where you round, should be 0.61, and that's money there that we are talking per dozen. Okay, per dozen. Okay, interpret the slope of the regression line on average for each additional egg. The price per dozen. Okay, is it increasing or decreasing? Well, B is negative, right? B is negative. It's decreasing, and it decreases. Okay, and we would say by, and it's not a lot, right? It's 0.0004. Okay, and that's for each dozen, which obviously, like you're saying, like that's less than a cent, and you're right. But when we're talking about 1,600 million eggs down the road, well, then that's going to add up to something, right? And then interpret the y-intercept of the regression line. Okay, well, y-intercept is saying for like when x is 0. So for no eggs, the model would predict 1.25. Where does that 1.25 come from? That's your y-intercept, right? 1.25 per dozen. Okay, for no eggs. Again, y-intercept doesn't always make the most sense, but that's what the model is predicting. Okay. Going on to the last one. Let's see how I'm doing on time. Got about 9 minutes to try to get through all of this. I'm not going to do the full scatter plot, but here's what you would do. Okay, read this, see what we're talking about here, and it says, hold on, let me read. Okay, up here. Weekly record of the number X of TV ads. That means TV ads goes down here. That's your X axis. And number Y of cars sold. So that means cars sold should be over here. Remember, don't forget your labels on your test. Lots of you lose points because you forget to label. Okay, and then watch what your X's do. Your X's go as high as 25, as low as 6. As low as 0 actually. So I would probably just count by fives down here, and I'd go 5, 10, 15, 20, 25. Oh, it goes up to 28 even, so 30. Okay, I'd probably count by fives like that. And then your Y's go up to 40. Okay, and you don't have much room here, so I'd probably count by tens over here. Okay, again, that's kind of up to you, but you want to pick something that works well where your data is not super clustered. So make your life easy by checking out how much or how low and how high each go, and then figure out what to count by based off of that. Okay, I think you know how to plot points, so I'm not going to do all of that. And then this, you are entering all of this into your calculator. I will go ahead and do that very fast because that obviously is a big part of this. So you go stat, edit, enter, clear your columns. Said I wasn't sure if I was going to do this, but I'm just going to do it. I think I have enough time. So we got 6, we got 20. I'm entering all my x values. 0, 14. I'm not going to say these out loud. Okay, there's all my x values, and I go for my y values. Okay, got them all. Scan over to make sure we're looking okay. Looks good to me. I go zoom 9. That gives me that zoom stat. That's how your scatter plot should look. It should look something like that. So it's kind of cool to see that. And now, when I want to find R, my line of best fit, and all of that stuff, I go to stat calc 8. Okay, and I am entering through this to get all of my stuff. Okay, so there's all my stuff. That's what you should have popping up on your calculator, and we're going to use that to answer the next few questions. Okay, also based off of your scatter plot, you should see, and we saw it when I hit the zoom 9, do the data appear to have positive linear correlation, negative, or no correlation? It does seem to like have a pretty strong linear correlation, and that is a positive linear correlation because you should see as X increases, so does Y. Okay, in other words, as TV ads increase, because it's saying explain, so don't read over that. Make sure on your test you are explaining if it says explain, because that means you're getting a point based off of that. So as TV ads increase, cars sold increase also. Okay, which makes sense, right? That's why people pay to have commercials and have ads out there, because it is it's an ad, right? It advertises for their company so that they can sell more. Okay, our R, when we put all this in, our R is 0.919. Okay, that's right. My calculator is straight up telling me that. That tells me, and again, you saw it in your scatter plot, like when you graphed it. Again, I didn't do it because I trust you can plot points, but that R confirms that, yep, there is a strong positive correlation or association. Okay, that's what that 0.919 means. Again, don't read over the what can you conclude. Make sure you're just doing that, just like you're explaining here. Those would be worth like 2 points, one for the R, one for the explanation. Okay, same here, one for positive and one for what that means. Okay, going on to D, find the equation. Okay, well, this tells me that again, when I say this, I'm talking about my calculator, tells me that A is 6.54, and again, it's always A plus BX. My B is 1.01, so plus 1.01x. Okay, compute the sample means. Okay, to do that, I'm adding all of my x values up and I'm dividing by however many there are. So I'm going up here and I'm going 6 plus 20 plus 0 plus 14 plus 25 plus 16 plus 28 plus 18 plus 10 plus 8, dividing by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because there's 10 of them, and you should get 14.5. Do the same thing for your y's. Add up your y's, divide by 10, because there's 10 of them, and you should get 21.2. Again, I know I'm going fast, but I have a class coming really soon. The bell's going to ring soon. How many cars can the manager expect to sell if 10 ads per week aired on TV? Okay, use the equation of the line, and it tells you when X is 10. If it didn't say this like second sentence, you should be able to read this first sentence and know I'm putting in 10 for X here in my equation. And when you do that, you're doing 6.54 plus 1.01 times 10, you should get 16.64. Okay. Find the residual. Okay, the residual for 10 comma 12. Well, your residual formula is y minus y hat. Again, that's actual y minus predicted y. Okay, so for that, you are doing 12, okay, minus, okay, because that 12 is your actual y, right? So 12 is your actual y minus the y hat. Well, this is your y hat for 10, right? We put in 10 for x, and this is what we got. This is the predicted y. So minus 16.64, which gives you negative 4.64. That is your residual, okay? That is your residual. For the residual above, the actual value is higher or lower than the model predicts. It's negative. It's a negative, it's a negative residual, which means it is lower, but you're also saying, okay, the actual y is 12, the model predicts 16.64, so again, that's another way you can say, okay, well then the actual y is lower. Okay, interpret the slope for the least squares regression line. Okay, that tells us on average, okay, our slope is 1.01. So on average for each TV ad, okay, and that's, you're always going to use your X, and our X here is TV ad. So for each TV ad, on average for each TV ad, the number of cars sold, again, that's our Y, so that's when you go to your Y, the number of cars sold, well, what happens? They increase, cars sold increase by 1.01, right? Because that's our slope, so by 1.01. That's interpreting the slope. Okay, and that's a wrap on your Chapter 9 review video. Please ask me if you have questions on anything. I know it had to be quick. Hopefully it was helpful. I will catch you guys later. Good luck on your test.